Hey guys, so in this video I'm going to show you how to implement the swamp houses. The houses are these 5 locations at the top of our game, and it's basically where we are trying to take the frog into. So what happens when a frog reaches one of these houses, and let me try to see if I can reach one of them here. What happens is this: when we can enter the frog inside one of the houses, we just add this house frog a sprite on the top, and the frog goes back to the beginning. And the objective for the level is to fill all 5 houses with frogs. So let me show you what I did to implement this. First thing I did was creating the house frog. This is an actor that has 2 different sprites for the animation. I imported the image, I changed the animation to 300 milliseconds each one of the frames, so the animation is like slower. And the only thing else that I did was on the properties, I changed the collision group so that the actor does not collide with anything. It's basically like a placeholder. We are not using it for collisions, for anything else. So this is a house frog. And now, the second thing I did was changing the way that we were detecting if the frog could move up or not. And if you remember, here on the frog movement, we had this list of values, or that we called entrances, which were the exact position that the frog needed to be so that we could let the frog move up. Now, the problem was that, this was working before because we were moving the frog always aligned with the grid. So the frog would always move 32 pixels. And so from the beginning to the end of the game, the frog was always moving inside the grid. And so the frog, when reached this position, it would be exactly on that value that we have, like 16 or 112, and so forth. Now, the problem now is that since the frog can be transported by the logs or by the turtles, it means that the frog won't always be aligned with the grid. So the frog can be here, the frog can be anywhere in this range of positions. So we can no longer expect the player to have the frog on that exact position to let the frog move up. So what we'll do is that instead of having an exact position, we are going to create a range of positions that indicates that the frog is at the entrance of the house. So instead of being exactly at 16, we are going to give an offset, and with that offset, we are going to create a range from the original position, from 16, and we're going to use that offset to create a range from the original position minus the offset and the original position plus the offset. For example, I'm using right now an offset of 4 pixels, so it means that the frog will be able to enter the house if it's anywhere between 16 minus 4, so 12, and 16 minus 20, 16 plus 4, so 20. So if the frog position is between 12 and 20, then we let the frog move up. And this makes it easier for the player, of course, and you can even increase the offset if it's still too difficult. We can increase the offset. As bigger the offset, easier for the player. And we need to do this because if the player misses the house, tries to move the frog when it's, for example, like here. If we try to move the frog here, then the frog will drown. So one of the aspects of the game is also that you need to time precisely when to move the frog to get inside the house and not get on these like bushes or what's this around the houses. So let's see how to implement this offset in the game. So basically we had the entrances. I created a new attribute called entrance offset, and this is a public variable as well. So we can, a default value is 8, not 4, actually it's 8, so it's easier. But I believe that I ended up changing the value to 4 later. So on the frog movement, yeah, you can see the entrance offset is now 4. And I have this public, I don't know why, but I don't need to have this public. But the entrance offset, yes, so that we can just easily change here the value and just test if it's too difficult or too easy, so we can do that here. And now what I ended up doing was changing the up condition that we had before. So before we had if up was pressed and the Y position of the frog was bigger than 96, then it would move up. And I ended up changing this so that when the up is pressed, we first check if the Y position is greater than 96, it moves up. It means that the frog is still on lower than the entrance of the house, so we can just let it move forward. Otherwise, I mean else, so if the frog is already on the position at the entrances of the house, what we are going to do is that we are going to actually let the frog move up, because we want to catch the mistake not only when the frog moves into the house, but also when it moves into a bush, for example. So otherwise, we are always moving the frog up, but if the frog is not at the entrance of the house, then we drown the frog. So we just kill the frog. It was a mistake, and the player loses a life. And the offset is now used inside this is at any entrance. This was where we were comparing the position of the frog with those exact values on the list. So this is where I ended up changing to create the range that we talk about. So instead of comparing the exact position, the position of the frog with an exact value, what I'm doing is that I'm going to return true, meaning that the frog is at an entrance. If the x position of the frog is greater or equal to the value in the list, so let's suppose we are dealing with the first one. So the value on the list 16 minus the entrance offset, in this case minus 4, which is the value that I have now, so 12. And if the position is less than or equal to the item on the list plus the offset. So like I told you, we are going to return true if the position of the frog is between these two values. And it needs to be between the minimum value and the maximum value. The minimum is equal to the value on the list minus the offset, and the maximum value is equal to the value on the list plus the offset. When the frog is between these two values, within these two values, counting with the values also, then we return true because the frog is at an entrance. But we are no longer using this to move the frog. We are always moving the frog. We are using this to know if the frog actually entered the house or if we should drown it. So this was the first change that I did. So now we can move the frog up, and if the frog moves until that line and it's not inside any entrance, it moves up again, it means that we should drown the frog. Now, the second thing that we need to do is to detect if the frog is actually inside the house. And because now that I'm thinking that we could use this, I mean, if you move up and if it's at any entrance, it means that inside the house. But then we didn't know exactly the position where he's at. So what I ended up doing was I finally found a way to use regions. Like I told you before, regions are just areas that you can draw in the game to detect when an actor enters that region or exits that region, that area that we draw. So what we are going to do now is to create regions inside the spaces of each house, and then detect if the actor is inside that space or not. So I created a new behavior called house spawner. Just like with the other ones, I have the turtle spawner, the log spawner, now we have the house spawner. Why is it a spawner? Because we are going to be creating the houses, the regions in code instead of drawing them in the scene. We could also draw them in the scene. I believe I showed you this before, so we could come here to the scene and just, add regions, so we could just like draw regions here. But I prefer to do it by code. It's more precise and less work in a way. So, and now let's break down this code that I have here. Okay, the first thing that I have is a list. So I created a list where I can store the regions that I'm creating. And this is because while we have an event here that tells me if an actor is entering or leaving a region, I didn't find a way to have this for every specific region that I'm creating through code. So what I ended up doing is that I'm creating the regions and storing that regions on a list. That's why I have this set houses to create new lists. So a house is a list, basically. And this is something to remember. Every time you create a list, you need to initialize the list first. I mean, if you don't add any values here, it means that the list is not empty, is different than empty, is null, which means that the list does not exist, it was not initialized. So every time before you start adding values to the list, you need to set houses to create new list. So this is like initializing the list, creating the actual list. And now I'm going to go back to this one in just a bit. And now we are going to repeat 5 times. So we have 5 houses. And I'm just creating regions at the position of the houses. And the position, so I know that the first house starts at 16, which is like this. And each house is 96 units apart. It's like 3 tiles of our grid. So we start at 16, and then we add 96 times the current loop count. It means that the first one, the current loop count is 0, so it's going to be at 1664, which is the height of the third row, and with the size of 32 pixels by 32. So this creates all the 5 regions. And then what I'm doing is that I'm adding the last created region, so the region that we just created here, to my list of houses. And now I have a list with all the regions that I created. And also you can see that we have another list called house occupied, and this is another list where I'm saving if I'm storing if that house already has a frog in it or not. And this is because as soon as we move a frog into one of the houses, the house gets occupied. And so if I try to move another frog into it, we lose that frog. So it's a mistake and the frog drowns because the house is already occupied. And so I have another list to store those values. So I know that if the house number 1 is occupied, I'm going to put the first item on this list as true, and house number 2 as true as well, and all of them. And what we need to do here first is that create a new list. So set house occupied to create a new list, and then set the initial values to false. So we are going to set all the initial values to false. So we add the region to the houses, and we add a false value to the house occupied, which means that we are going to have a list with the 5 regions, and we are going to have a list with 5 false values. So this creates the regions, and now I added a new event, update event. That's where I'm checking if the player is inside of any of these regions. Like I told you before, I couldn't find a way to use the event. So we have this event, once again, enters or leaves the region, but I couldn't find a way to use the regions that I already had on the list. So it seemed like I either created attributes for each one of the regions, or I couldn't, and then I would have to create 5 events, 1 for each region, or I didn't see an easy way to do this. So what I ended up doing was adding this loop, this update loop, and here I'm repeating for the number of items that I have in houses. So I'm repeating for all the houses that I have in my list. And what I'm doing here is that, let me break, sorry, let me break this. Okay, so I'll come back to this in just a bit. Okay, what I'm doing is that if, and this is the way that I'm getting the player, because I didn't have a way to have access to the frog from the house spawner. And we have this block from the scenes regions. So that tells me, scenes regions, yes, we have this one. If an actor is inside a region, it returns a true or false value if the actor is inside the region. But I didn't have a way to choose the frog from here. I didn't have a way to access the frog, and I couldn't use an actor type. So what I ended up doing was I went to the game manager script, and when we are creating a player, I added an attribute called player, which is of type actor. And each time we create a new frog, I'm setting that frog as the player. And then I can access the game manager to get the player, and in this case get the actor. So what I'm doing, I'm using this for this scene get player from behavior, and this is from the behaviors, the attributes, and I'm using this so for this actor for this scene actually, because this behavior is attached to a scene. So for this scene, I'm getting the player attribute from the behavior game manager, and this gives me the frog, the actor that is the frog. And so if the frog is inside and I'm going through each one of the regions that I have inside the houses list, if the frog is inside one of the houses, what I'm doing is that first I'm checking if the house is occupied. And if the house is occupied, it means that we already have one frog inside that house, we already filled that house with one frog, then I'm just drowning the frog. So I'm using the block from the frog collision we have here on the custom. So I'm using frog collision, we have the drown, and I'm saying, okay, drown, and I'm using again the same block to get the actor of the frog. And I'm saying, okay, drown the actor. Otherwise, meaning that if the house is not occupied, then I'm replacing the item in the list house occupied to true, meaning that I'm changing the value of that house to true. That house is now occupied, and I'm accessing the item with the current loop count because we are iterating through all the houses, and all the houses have an index. So if you go here, attributes house occupied, we don't see it here because we don't have values, but each house is going to have an index and a value. So in this case, the house occupied has index from 0 to 4 because we have 5 houses and the values are all false. And what I'm doing is I'm replacing the item of the current loop count because we are iterating through the houses, and I'm changing the value to true on that list. And then after this, I'm creating a house frog. So I'm creating the actor that we added with that small animation of the house frog, and I'm creating that house frog at the position of the house. So, and I'm getting the position with this like block, gigantic block here, which basically gives me an X position and a Y position of the region. And I'm getting that from here, scenes, regions, properties. We can have an X of region. So this gives me the region. This returns me the region that's inside the houses list. And I'm using this block to get the X position of the region and the Y position of the same region. And I'm creating the house frog. And then I need to tell, and the frog wins is also a new custom block. That basically I'm telling the game manager, this is a custom block that I created on game manager, and I'm telling the game manager, okay, so the frog wins, and now reset the game, send the new frog back to the beginning so the player can keep playing. And let me just show you what this frog wins is. This is something that I will also change on the game manager. Before we only had this spawn player that basically spawned the frog at the initial position, and we were using this from the frog collision when we were killing the frog. And now, but now I added two different blocks, one that says frog wins and one that says frog loses. So when the frog wins, the game manager kills the player, so kills the frog, and spawns the player at the initial position. So creates a new frog at the initial position. And when the frog loses, right now it's doing exactly the same. But the idea here is that since I have these two methods now, I know that when the frog wins, I'll probably add some score to the player and reset the frog. But when the frog loses, I'm gonna take one life out of the player and reset the frog. So now I have these two blocks that I can use throughout the game to just create this game logic. And I ended up also, since I created these two, we were using the spawn player on the frog collision, and I changed the frog collision. So when we are destroying, instead of spawning the player, I'm just calling the frog loses. That's exactly what we want here. And here on our spawner, so the frog wins, which is we're going to increment the score and reset the frog back to the beginning. And this is the whole thing about making the frog inside the house. And I also had to add this, that's why I leave this for the end, that I was having a problem was that because when we were moving the frog to inside the house, we were drowning the frog because we are doing that here on the frog movement. So if the frog was not at any entrance, we would drown the frog. But what was happening was that even despite we are drowning the frog, it takes some time when we are drowning the frog. I mean, we are not like killing the actor. And since we are drowning the frog and playing drone animation and all that, what was happening was that the region was still detecting the actor inside, and so was still running this entire code. So what I ended up doing was that when we kill the frog, when we drown the frog, here at the frog collision, I added a new attribute that tells me that if the frog is dead or not. And as soon as we try to destroy the frog, we set this attribute to true. So when we destroy the frog, you can see that set is dead to true. And now on the house spawner, I can say, okay, but if the player, once again I get this same block, if the player is dead, which means that we are already trying to drown or kill the frog in some way, then I just exit the loop. And this exit loop is a new block. Wait, sorry. Here. And this exit loop is a new block from the flow loops, has exit loop. And what this does is that, okay, if the frog is dead, then I don't want to run any more of this. I don't want to run any of this code, but also I don't want to run continue repeating for all the other houses, because it doesn't make any sense because the frog is already dead. So when I use this exit loop, what it does is that it just jumps out of the repeat block and starts again from the beginning. And here, we have these two blocks in the branching, just to explain to you the difference between both of them. The exit loop basically jumps out of the loop. So if we are inside a repeat block, for example, or any loop, actually a while loop or repeat until, when we are inside any of these loops, we can use the exit loop to just jump out of the loop and continue the execution afterward. In this case, I'm jumping out of the loop, and since we are inside an update block, an update loop, it's going to start again from the beginning. And we also have this return to start of the loop. Return to start, what it does is that it does not jump out of the loop, but it jumps from this iteration. So let's suppose that I don't want to run this code for this specific iteration, but I wanted the loop to continue. So I can use this return to start of the loop, and what this does is, instead of jumping out of the loop, it jumps again back to the beginning without executing what's beneath. So, but in this case, it didn't make sense, because we don't want to keep repeating the loop until the end, because if the frog is already dead, it's going to keep just running this inside the loop. So we can just forget the loop altogether. And yeah, I think this is it in terms of the changes that I did. And so frog movement, we changed this, we changed the is at any entrance, we create the house spawner, and this is the whole code to get the frog inside the house. Let me just test it to see if I didn't break anything when I'm like moving stuff around and changing things. Okay, so we have our frog. We can just move up. I died there, I don't know why, but oh, you see that I missed the house. Maybe I can increase the offset, I don't know, but it needs to be really perfect to get inside the house. Now it's okay. And yeah, this is it. Now that we have the swamp houses, we can start implementing the whole game logic. I mean, in terms of score, adding the time of each level, and adding the user interface, and that's it. Okay, so yeah, this is it. So thank you guys. I'll see you in the next video.